Question number 14. We want to determine the x and y intercepts for the given function. First, I just want to go over some graph and show you what x and y intercept mean, even though you don't know how to graph the functions that I'm going to show, but I just want you to see what it is. So let's say if I have a graph that looks like this is a graph, a parabola. This is called a parabola. Looks like a U, the black graph. And if they tell you for this graph, find your XY intercepts, what they're looking for is the following points. This point, this point. These are called your x-intercept. So red points are the x-intercepts. You have two of them. And the reason we call them x-intercept is because the graph crosses the x-axis. This is your x-axis. The black graph crosses this blue line here, so we call it the x-intercept. Not this point, not this point, not this point. These 2 points are crossing the blue line, horizontal blue line. So suppose that this point is +2 here. Let's say this is +2 here. X is +2, and suppose this is -1 here. So then you say the x-intercept is, if you want to say the coordinates of this point, you say x is 2 and y is 0. So when the x-intercept is a point where the y value is always 0. This is your other x-intercept. In this case, x value is -1, y again is 0. So the x-intercept's y value, the second value, is always 0. Let's say they say, find the y-intercept for this graph. By looking at the graph, you see that the graph crosses the blue line, blue vertical line here. So if this is -1, -2, let's say this is -3 here, then the y value is -3, where the x value of this point is 0. So the x value of this point is 0, the y value is -3, and we call this point y-intercept. So y-intercept has its x value always 0. X-intercept has its y value always 0. Let's look at another example. Let's say this time I have this graph. So let's look at this graph here. Let's say I'm just going to label them right now. -2, -1, +1, +2, +3, 4, and let's say this is 5. This is your x-axis, y-axis. We want to find the xy intercept. So let me label these as well. This is 1, 2, and so forth. So I put some labels on the y-axis, some label on the x-axis. We want to find our y and x intercepts. For x-intercept, we look to see where the graph crosses the horizontal line. This is our horizontal line, and the graph is crossing it here. So that's one x-intercept, -2, 0, because x at this point is -2, but the y value is 0. Another one is this point, where x is 1, y is 0. This point here on the graph has a 1 value for x, but the y value here is 0. Then this one. This point has an x value of 3, and its y value again is 0. And lastly, this one, its x value is 5, y value is 0. So the blue dots are the x-intercepts. So this is an x-intercept, x-intercept, x-intercept. Let's find the y-intercept. The y-intercept is where the graph crosses the y-axis. You see this is the y-axis here. That's where the graph crosses the y-axis. That point is x is 0, y is 1. So then this is our y-intercept, and the blue ones are called the x-intercepts. However, now we have an equation that we don't have its graph. We don't know how the graph looks like for us to find x-y-intercept. How do we find x-y-intercept of such problem? So this is how we do it. First, I'm going to write the equation. Qx is equal to 2x minus 14. Remember, I have an equation. I could also call it y. Instead of qx, I call it y. And instead of putting it on the left-hand side, I put it on the right-hand side. It doesn't matter what side you put that qx. So I change qx to y. This is my qx. And instead of being it on the left of 2x minus 4, I put it on the right. And that's perfectly fine. And the reason I did that because I want to have my input as a bubble here, and then y is the output. Y is a qx, and all is telling you these two are the same thing. Qx and y are the same thing. This is more descriptive, is telling you that x is the input. That's all it's telling you. So, when you're looking for y-intercept, do you remember the pictures? We always had x is equal to 0. So we said for y-intercept, x is always 0. For x-intercept, we always had y equal to 0. Let's first find y-intercept. So when we look for y-intercept, we want x to be 0. So how do I find the x-intercept or y-intercept when I don't have a graph and I have the equation of the graph? So y-intercept says x is 0, x is the input. So we are going to put 0 in here for x. Our input is 0. And then what do we get? We get 2. We change x to 0. If we have 2x, we write it like that, but as soon as I change x to a number, I should put parentheses. Because if I don't put parentheses, then this looks like 20. 2 is being multiplied by x. We change x to 0, so we want to multiply 2 by 0, so we put parentheses around it. That means multiply 2 by 0. And this means multiply 2 by x. So when we have x, we don't have to have parentheses, but when we change x to a number, we must put the parentheses. And then what do I have here? Minus 14. So I put minus 14. And I use PEMDAS to find out what this is. You have to do multiplication first. 2 times 0 is 0. So I get 0 minus 14. 0 take away 14 is minus 14. If you have a 0, you add it to 2, you just get 2. If you have a 0, you subtract 4 from it, you get negative 4. So nothing happens when you add 0 or subtract 0 from anything. So when x is 0, the output is negative 14. But when x is 0, this is how we find our y-intercept. So when x is 0, y is negative 14. That's our ordered pair. And we call that y-intercept. So y-intercept is 0 minus 14. And next, we want to find the x-intercept. To find the x-intercept, we write the equation. And what was our equation? Our equation was 2x minus 14 is equal to y, or qx. But we want y to be 0, so I changed that to 0. This is called a linear equation. The reason we call it a linear equation, because we have an x, and x has a 1 exponent. So when you have an x and your x has exponent of 1, there is no exponent, that means the exponent is 1, then we have a linear equation here. So that's called a linear equation. And in order for me to solve this equation, I want to get x by itself. To get x by itself, I have to get rid of this negative 14, and then I have to get rid of the 2, following certain rules. So you must get rid of the negative 14 first, then you have to get rid of that 2. So 14 is being subtracted. 14 is being subtracted from x. Really from 2x. So opposite of subtraction, if you go to your PEMDAS again, parentheses, exponent, multiplication, division, addition, subtraction. Have this in front of you and say, what is opposite of subtraction? Addition. And when you're solving equation, instead of starting from the parentheses, going to exponent, and then multiplication, division, go this way. Let's start from the bottom. See which one of these you have. Do you have addition or subtraction? Right now we have subtraction. And opposite of subtraction is next to it, addition. So then I have to add a 14 to both sides, just like that. Then you're going to add these guys. You have 2x minus 14 plus 14. If I have 14 and I take away 14, I get 0. You have 14 candies, you take away 14 candies, you have nothing. So that's gone. But 0 and 14, when I add them, I get 14. Next, I have to go one step up. With respect to x, I have a multiplication here. I have 2 times x, 2 times x, 2 multiplied by x. And opposite of multiplication is division. So what do I divide with? I divide with this guy, 2. So I get x is 14 divided by 2 is 7. So x is isolated, x is by itself. My solution is on this side. So when y is 0, when I substituted 0 for y, I got x is 7. When y is 0, my solution is 7. That's my ordered pair. So when output was 0, I went backward. I said, if y or output is 0, what do I trace it back to for input? Input must be 7. And that is called the x-intercept, 7, 0. So in other words, if I put the graph, if I want to graph this, when x is 7, y is 0, I go 1, 2, 3, 4, 5, 6, 7. That's one of the point. And then y-intercept is negative 14. So let's say this is minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 14. So when x is 0, y is negative 14, this is 1 point. And since this is a linear equation, I'm just going to connect these 2 points. And that's my graph. Remember, for the previous example, what I did was I showed you, I said, where the graph crosses the y-axis is called the y-intercept. So this is the graph of this equation. And look, is crossing the x-axis here at 7, 0. and it's crossing the y-axis at 0, minus 14. And that is your xy intercept. So I'm going to, again, erase. So we had 7, 0, 0, minus 14. We want to find xy-intercept of the next equation. How do we find xy-intercept of this equation? We are going to solve this equation. So we write minus x to the power 2 plus 12 is equal to y. I usually change this qx to y. So to find the y-intercept, we input 0 for x. Input 0. So I put 0 here. What do I get? I get negative. I have a negative. I change x to 0. And then I put a 2 here. You could put this inside the parentheses. 0 to the power 2 means 0 times 0 is 0. Negative 0 is the same as 0. 0 plus or minus any number is the number. So then y is going to be 12. This whole thing becomes 12. So when x is 0, y is 12. So from 0, we go to 12. That's the output. When input is 0, because 0 squared is 0, minus 0 is 0, 0 plus 12 is 12. So when x is 0, y is 12. That's our y-intercept. How do I find the x-intercept? So this is our equation. When we find the y-intercept, we are going to trace back. We are going to put 0 as our output and then see what it traces back to. What is this x? So to find the x-intercept, we are going to let y equal to 0. And then we want to find the x. So let me do that. Let me change this to 0. Let me get rid of these pictures. That's how you find your x-intercept. You change your y or you change your qx to 0. And then you solve the equation. Remember, I have parentheses, exponent, multiplication, division, addition, subtraction. So go this way. With respect to x, see what you have. I have a plus 12. So I have addition. I have a positive 12. I'm adding 12. So I need to subtract 12. So I subtract 12 on this side and on the other side. You have to subtract the 12 from both sides because you have an equation. Whatever you do to one side, you must do it to the other side. 12 minus 12 is minus 12. Then you go to the next one, multiplication, division. You say, is anything being multiplied by x? Yes, you have a negative being multiplied by x. You have a negative next to x. This negative in reality is negative 1. So you have a negative 1 that is being multiplied by x. So when it's a negative 1 in math, they don't put the 1. So, but you should put the 1 so you see what is being multiplied by your x. So what is opposite of multiplication? So we have a negative 1 and being multiplied by x. So what do? We do the opposite. We divide by that negative 1. So we divide negative 1 on this side, we put negative 1 on this side. So what do I get? I get x to the power 2, negative divided by negative is positive, and 12 divided by 1 is 12. So negative divided by negative is positive, just like when you multiply. When you multiply two negative numbers, you get positive numbers. When you divide two negative numbers, you also get positive numbers. So the same rule is true for both operations. If you divide a negative and a positive, this way or this way, the top is positive, the bottom is negative, or the top is negative, the bottom is positive, the answer will be negative for both of them. The same for multiplication. When you multiply a negative by a positive or positive by a negative, the answer is negative. When you subdivide, when you divide a negative by positive or positive by negative, you get negative answer. So the same rule applies for both multiplication and division. The same rules. So anyways, negative divided by negative is positive. 12 divided by 1 is 12. So I did that. Then I go up the ladder. I have to get rid of the exponent. How do I get rid of that exponent? To get rid of the exponents, this is a 2. You put a square root on this side and you put a square root on this side. But this side, the side that has a number, you have to put a positive and a negative next to the square root as well. Not on the x side, but on the number side. So you're just following these rules. So I had x squared is equal to 12. I want to get rid of that 2. I have an exponent. I want to get rid of it. To get rid of that 2, you put a square root here, you put a square root here, but the side that is a number, you just put this positive and negative. So you get x is equal to positive, negative, the square root of 12. You are not done yet. So for this exercise, they don't want you to leave this as a square root of 12. They want you to simplify it a little. How do we simplify a radical? So let me erase these. So we got the square root of x squared, which is equal to x. This becomes x. So let me write it as x. Is positive and negative a square root of 12. For a minute, forget about this, and I just want to show you how you simplify this. You break 12 into its prime factors. How do we break 12 into prime factors? You say 12 is an even number, so it's divisible by 2. 12 divided by 2 gives you 6, or 6 times 2 is 12. You cannot break 2 to any other two numbers. 2 is made out of 1 times 2. But 6 is divisible by 2, so you can write 6 as 2 times 3. 2 is already prime because you can't write it as any other two factors. And 3 is considered prime. You can't write it as any factors. But 6 is not prime. 12 is not prime. These numbers are not prime because you can write 12 as 2 and 6. You can write 12 as 3 and 4. So we don't call them prime numbers. 6 can be written as 2 and 3. We don't call it a prime number. But 2 is called a prime number because you can't factor 2. 3 is a prime number. You can't factor 3. So you start with the number. You break it into little pieces until you can't factor them anymore. So the bottom of the branch, 12 is the bottom of the branch. 2 is the bottom of the branch. This 2 and this 3. Those are the bottom of the branches. So therefore you write 12 as 2, another 2, and another 3. So that's the first step. You're going to break your 12 in its prime factors. 2, 2, 3 are the prime factors of 12. 12 is 2 times 6. 12 is 3 times 4. 12 is 2 times 2 times 3, right? These are all factors. These are called factors of 12. We don't call these guys prime because 6 is not prime. 6 is not prime, so we don't call these prime factors. 3 times 4 is not considered prime because 4 is not a prime number. But 2, 2, 3 is considered prime factors of 12 because 2, 2, and 3 are prime numbers. So once you have the prime numbers, then you go and see if you have double of anything. You have 2 2's. Because of the square root, they come out as 1, 2. So if you have double of anything, comes out as a single one outside the radical. So that is your answer, 2 square root of 3. Remember, you had a positive and negative. So you say my x-intercepts are 0, comma, positive 2 square root of 3, and 0, comma, negative 2 square root of 3. That's how they want you to write your y-intercept. I made a mistake here. This is 0, 12. Sorry about that. This one was correct. This one I made a mistake. So my x-intercepts are 2 square root of 3, comma 0, negative 2 square root of 3, comma 0. I want to do 2 more examples like these. So I'm just going to change the numbers and go over 2 more examples, one for each. Let's say I have q of x is equal to 3x plus 2. And I want to find my, or 3x plus 6. I want to find my x and y intercept. So instead of that, this is what we have. Remember, the first step, I always like to change that q to y and write it on the right-hand side, because y is the same thing as this whole thing, qx. Don't think this is q times x. This is not q times x. All this says that x is your input. So if you had 3t plus 6, this would have become qt. All is telling you that t is your input, is not q times t. So anyways, I'm going to put input 0, see what output I get. So when I put 0 here, I get 3 times 0. Since 0 is a number, I put it inside the parentheses because this means 3 times x. When we have x, it's okay not to have a parentheses, but you change x to a number, you need to put your parentheses. That's 6. Order of operations says do the multiplication first. 3 times 0 is 0. 0 plus 6 is 6. When you add 0 or subtract 0, nothing happens. You just get the number. So what is this? This is your y. So when x is 0, your y becomes 6. So that's your order pair. So then if this is our equation, then y-intercept is 0, 6. We want to find the x-intercept. To find the x-intercept, you write 3x plus 6 is equal to 0. We make the output 0. We want to trace the input. What is the input? If the output is 0, what was the input for it? So we have to solve an equation. When you're solving this type of equations, just write your PEMDAS exponent multiplication, division, addition, subtraction. Start from the bottom and say, do I have addition or subtraction with respect to x? You have addition. You have plus 6. So do opposite of addition, which is subtraction. Subtract 6. So you put a minus 6 here, you put a minus 6 here. You get 3x is negative 6. Go to the next operator, multiplication or division with respect to x. You have multiplication. You have 3 times x. So you have 3 being multiplied. Do the division. Divide by 3. So you get x is negative 2. So if y is 0, x is negative 2. Again, to graph this equation, because it's a linear equation, in order for me to graph it, it says your x-intercept is negative 2. So this is your x-axis, this is your y-axis, this is negative 2, 0, this point. And this point, x is 0, y is 6. So 2, 4, 6. That's this point. Since it's a linear equation, if I connect them, I have my graph. Again, where the graph crosses the x-axis is x-intercept, where the graph crosses the y-axis is your y-intercept. So that's that. Let me make another example for the next problem. Suppose instead of this equation, we have q of x is equal to minus x to the power 2 plus 18. So I write my equation. First, I do the easy one, finding y-intercept. For y-intercept, you input 0 for x to find your output. So you have negative 0 squared. If you want to put parentheses, go for it. Let's find out what we have. When we are evaluating, we go this way. Inside the parentheses, there is really nothing. We have an exponent of 2. What is 0 squared? It means 0 times 0. But 0 times 0 is 0. Then you have a negative 0. What is negative 0? It's just 0. So negative 0 is 0. Positive 0 is 0. So you just have a 0 here. What is 0 plus 18? Just 18. So you get y. X is 0, y is 18. So when x is 0, your y is 18. Then we are going to do the find the x-intercept. To find the x-intercept, we are going to let y equal to 0. So we write our equation. We subtract 18 from both sides. We get minus x to the power 2 is equal to minus 18. So let me just write my PEMDAS again. So I'm just starting from the bottom. I say, do I have addition or subtraction? I see that I have a plus 18. So I have an 18. I subtract 18. So 18 minus 18 is 0. 0 minus 18 is minus 18. Do I have multiplication? You might think you don't have anything being multiplied by x, but in reality, you have a negative 1 that is being multiplied by x. So when you have a negative, change it to negative 1. So I have a negative 1 being multiplied. I do divide. Oops. I divide and divide by negative 1. So negative over negative is positive. Negative divided by negative is positive. Negative divided by negative is positive. 18 divided by 1 is 18. Lastly, do I have an exponent? Yes. How do I get rid of that 2? I put a square root on both sides. That's how you get rid of that 2. But you have to remember to put a positive and negative. This 2 and the radical cancel, you get x. But how do I simplify 18? 18 is divisible by 2, and it gives me 9, because 2 times 9, check it. 2 times 9 is 18. 2 is prime, so I can't go further, but 9 is not prime. 9 is a composite number. It's made out of 3 times 3. 3 is prime, 3 is prime. I stop here. I have 3 prime numbers. So I write this as 2 times 3 times 3. I have 2 3s. They come out as 1 3. And 2 will not come out because I only have one of those. So the answers are positive and negative 3 square root of 2. So when I want to write my x-intercept, I write 3 square root of 2, comma 0, comma, negative 3 square root of 2, comma 0. In case if you're wondering why we put a positive and negative, I just want to give you one explanation why that happens. So anyways, this problem is done. That is the answer. And I want to give you explanation why we get a positive and negative when we have x to the power 2. But before I do that, let me show you the picture of what I just did. This one, it says negative x squared plus 18. So the graph of it looks like this. You will learn how to graph these kind of equations, but right now I'm telling you this is how the graph looks like. Oops. This is 18. That's your y-intercept right here. This is your y-intercept where the graph crosses the y-axis at 0, 18. And these are your x-intercepts. You have 2 of them. One of them is negative 3 square root of 2. One of them is positive 3 square root of 2. This is the graph, crosses the x-axis at those 2 points. Just give you a rough estimate of 3 square root of 2 is, this point here is about negative 4.2, about, and this one is positive 4.2. 3 times the square root of 2 is about 4.2. But anyways, I want to tell you why we get positive and negative of something when this happens. So I told you when you want to get rid of this 2, you put a radical here, you put a radical here, you get positive, negative. This side becomes x, this side becomes positive, negative 2. Why is that? Because what happens when I started with x squared is 4, and I say that either x is 2 or x is negative 2. Look what happens when I put 2 here. What is 2 to the power 2? 2 to the power 2 means 2 times 2 is 4. What is the answer when x is negative 2? I put negative 2 to the power 2, which is negative 2 times negative 2. That also gives me positive 4. So if I put negative 2 for x, I get positive 4. If I put positive 2 for x, I get positive 4. So that's why both of them are the solution when you have x to the power 2. You have both of them. I hope that makes sense to you. I'm going to stop here, and then we continue on the next problems.